Now I want to get into a subject which is quite difficult, and that has to do with change of orbits. Burning a rocket when you are in orbit and your orbit will change. And I will do it only for some simplified situations. I start off with a circular orbit, and I will fire the rocket in such a way that I will only fire it in such a way that my velocity will either increase exactly tangentially to the orbit, so that it will increase in this direction, or that it will decrease in this direction. So if I'm going in orbit like this, I either fire my rocket like this, or I fire my rocket like this. That is difficult enough, what we do now. So this is our circular orbit, its radius r, and at location x, at 12 o'clock, that is where I fire my rocket. The first thing I do, I increase the kinetic energy. So I fire my rocket, I blast my rocket, we go in this direction, I blast my rocket in this direction, and so the speed, which was originally this in orbit, the speed will now increase. I add kinetic energy, and now I have a new speed which is higher. If my speed is higher, then my total energy has increased. I increase the kinetic energy. The burn of the rocket is so short that I can consider after the burn that the object is still at x. It's a very brief burn. So the kinetic energy has increased, the potential energy is the same, so the total energy is up. And therefore, the total energy now is larger than the total energy that I had in my circular orbit. But if that's the case, then clearly 2a must be larger than 2r. I now go into an elliptical orbit because the new velocity is no longer the right velocity for a circular orbit. And so what's going to happen, I'm going to get an elliptical orbit, like so, whereby 2a must be larger than 2r because my total energy is larger. And you see that immediately when you go to equation number 5. If you increase the total energy, then your a will go up. Okay, so 2a is larger than 2r. That also means that the period, t, must be larger than the period in your circular orbit. Fine, so far so good. My other option is that I'm going to fire the rocket when I spew out gas in this direction, so I take kinetic energy out. So after the burn, my speed is lower. My speed is now lower. I have taken kinetic energy out. When I take kinetic energy out, the total energy is going to be less than the circular energy. 2a will be less than 2r, and the orbital period will be less than the circular orbital period, and therefore my new ellipse will look like this. And so these are the three situations that I want you to carefully look at, because I'm going to need them in the next very dramatic story, which has to do with a romance between Peter and Mary.